Hello, my name is Eleni Tsolaki and I am coming from the University of Crete in Greece. I shall be guiding you through this course called Probability and Statistics. The course combines two parts, probability and statistics, and we are going to see that the two subjects are actually very closely related. That's why we study them together. The probability is necessary in order to study statistics. So any book in statistics should have enough material for in probability. Anyone who would like to do more examples should get any book in statistics and find the section in probability and work on probability as well. Of course, there are books on only probability, as probability is needed for other disciplines too. I have tried to avoid the theoretical details of this course. I have avoided proofs of theorems, as I think that it's not necessary for this course. It's a more practical course. Anyone who is interested in the theoretical background of the course could read any introductory, I would recommend, book in probability or statistics. So, in this lesson, first of all, we are going to see what is probability about. What, in other words, what does probability deal with? When can one use probabilities? And why? Why do we need probability? Also, we're going to see what is statistics about. Why do we need statistics? Why should somebody study statistics? Also, we are going to see how probability and statistics are related. Why do we study these courses together? Finally, we are going to give basic definitions, and we are going to see examples. Examples that is going to put into practical context everything we are going to learn. In every lesson, there is going to be an example in any new notion that we introduce, so we can say in practical terms how we can use the theoretical background that we have discussed about. Probability. The first part of this course is probability, which deals with experiments with uncertain outcomes. Let's think about some examples. First of all, let's assume that we toss a coin. Now, when tossing a coin, we don't know what we are going to get before we observe the outcome. We don't know if it's going to be a head or a tail. We actually know that if the coin is fair, there is equal chance of obtaining a head or a tail. It is an experiment that results in an uncertain outcome, an outcome that cannot be predicted beforehand. That's where probability comes in. Probability will assign a value, would give us a number about how certain or as uncertain we are that an event will occur. When tossing the coin, of course we know that we are going to get one of the two results. We have an idea that it's going to be a head or a tail. It is important when we perform an experiment, as we say, we know what we may get. Now, the result, like when we play games with chances, we want to know what is the chance of winning something. When we play the lottery or we play the roulette, we would like to know if there is great chance of winning or not. That's where probability comes in. That's actually how probability originated. It originated from games of chance. Of course, it has to be studied as a mathematical discipline. Now, the uncertainty that comes in these experiments, it could be due to luck, like in the example we saw with tossing the coin, or it could be to other factors that we cannot control. Other examples with experiments that we cannot predict the outcome due to luck could be roll a dice. If we roll a die. If we roll a die, we know that the result we cannot predict. There is equal chance, if the die is fair, of obtaining a number between 1 and 6. Any number 1, 2, 3, 4, 5, or 6. Another example where the factor luck doesn't come in is to predict the temperature, let's say, for tomorrow. Now, if we take into account how's the weather today, if it's a nice day, high temperature, low temperature, and take into account other factors like if it's summer or winter, and so on, we can have an idea of what's going to happen. We can predict if tomorrow the temperature is going to be high or low. But of course, there are many factors that cannot be controlled, and that's why the conclusions we made, the result we reach, is not certain. That also happens when, for example, we cannot measure exactly some quantities. For example, let's say that a new medicine is introduced and the company wants to find out if it has more positive than negative results. So what we do is that we can measure how people react in this medicine and make conclusions about if it's a good medicine or not. There are many factors, there are a lot of people that we cannot, of course, test the medicine in all people. We cannot control all the factors. So what we do is that we are going to make conclusions that are not certain. They are most probably correct. So probability would assign a numerical value to an event which reflects its likelihood of occurring. Probability is the discipline that will give us a measure for this certainty or uncertainty. We all want to speak the same language. We all want, when we say that there is that probability of an event happening, to have the same measure, so that if we repeat the experiment, if somebody else repeats the experiment, we would have the same results. We don't want one person to assign one measure to an event and another person to assign another measure to the same event, because in this case we couldn't understand each other. We couldn't be speaking about the same thing. So that's where we need mathematical foundations. We need the foundations, we need the mathematics in order to be speaking about the same thing. So when one says, what is the probability of this happening? When we give an answer, we want to understand exactly the same thing. We saw many experiments. We saw some examples of experiments. So experiment is a procedure that results in a random outcome. Tossing a coin was an experiment. Rolling a die was an experiment. Another experiment would be to draw a card from a 52 cards, a deck of cards with 52 cards. When we draw a card, we would like to know what is the probability, for example, of drawing an ace. So that's where probability is going to give us the answer. What is the chance when I draw a card, that card is an ace? What is the chance when we play the lottery that we win? What is the chance when we go in the casino that we win? Because in life, more things are uncertain. We cannot know the result until we actually observe it. What we want to know is at least how possible it is for this, for an outcome to be observed or not. Statistics. The second part of this course deals with statistics. Statistics deals with collection and analysis of data. What happens is that in reality we cannot collect data from every single person, let's say, that we want to analyze. We don't want to collect data from the whole, from a population. We want to collect data from a small part of a population. We want to analyze data from a sample and then deduct conclusions for the population. If we think the example if we want to see if there is any relationship between the height and the weight of a group of people that live in a certain area, we are going to collect data, analyze them, and see if there is this relationship or not. Of course, if there are a lot of people living in that area, it's impossible or very difficult to collect all this data for every single person living in that area. What we do is that we collect data from a sample, a small group of people. How small this group is it needs to be discussed. It has to be not too small, it has to be representative of the population, so that the results that we are going to conclude for the sample would actually be true for the population. It can't be too big, it can't be almost the population, because in that case we can just collect data from the whole population and reach certain results, certain conclusions. So, the population and sample. The population is a set of elements that we are interested in, and the sample is a smaller group, a subset of the population. As we have seen, the sample, collecting the sample data for a sample is very important. It has to be, as we said, representative of the population. It has to keep the characteristics of the population. Like in the example, we saw that if we want to see if there is a relationship between the height and the weight of some people, there is no sense of going to a basketball game and collect data only from those people. We understand that the sample is not representative and that the results we are going to obtain are not going to be probably true for the population. Also, every time we collect a new sample, we want to know that it is more probable that we are going to obtain similar results for the population. We don't want every time we get a new sample to have different results. So we have to make sure that the sample that we collect is large enough so that we can reach reasonable conclusions, but not, of course, as we said, too large, so that it doesn't make sense to work with statistics. How probability and statistics are related. Conclusions from statistical analysis are based on some level of confidence, certainty, and probabilistic laws are needed. As we said, we are going to study these two subjects together, probability and statistics. We need probability in order to study statistics. Statistics is needed in order to derive conclusions for a population that cannot be measured exactly, and so we just get a small group from the population, we analyze them, and we make conclusions for the population. For example, in the elections. Before the elections, parties would like to know where they stand, if it is more probable that they are going to win or not, and see what they can do about it, and in order to win the elections. So what happens is, before the elections, it is not possible to ask every single person in a country what is going to vote. Before the election then, companies collect data, they collect samples, analyze the data, and see what people are going to vote. These results, these conclusions are passed to the parties to see how they are going to go on and if there is any possibility of changing the politics and winning the elections. So, conclusions from statistical analysis we said that they're important. They're important when we study phenomena that have uncertain outcomes, and we need to have some level of confidence. We need to be certain that the result that we have obtained, the result that we have reached, the conclusion we have reached based on the sample, it's in some level certain. We are going to perform, if we are going to perform the same experiment, we are going to get similar results. When the elections actually take place, we are going to observe similar results as the ones seen in the sample. It wouldn't make any sense if the results, the conclusions we have made are not very logical to appear the same in the population. Then there would be no need for statistics. So we need to measure this uncertainty. We need to measure this confidence if we are going to obtain similar results for the population. And that's where probability comes in. Probability would provide us with the laws, the mathematical background that is needed in order to measure how confident we are. Are we going to most probably observe the same results in the elections if nothing changed? If something changes from the time we get the sample, then we cannot expect to have the same results. If the population changes or other parameters changes, then we cannot say that the results obtained after analyzing a sample would be the same for the population. It is important to make sure that we define exactly what our population is and make sure that when we reach some conclusions from the sample, it's for that particular population. Let's see an example. A company produces light bulbs with two different methods, A and B, and wants to find out which of the two methods produces bulbs with longer life duration. This is an example that many companies, it's a problem that many companies may face. They produce something with 2, 3 or more different methods, or buy things from different suppliers, and of course they want to make sure that they are buying the best in the best possible price. So what happens in this case is that, of course, they cannot test every single part, every single element they buy and see what happens. They are going to test a sample. In this case as well, the experiment is that we have 1,000 bulbs which were made using method A and 1,000 bulbs which were made using method B. We have only two groups. Usually what happens is that company buys or makes things from using lots of different methods. The problem is more complicated, but in this case we are going to see a very simple example to understand what's going on. The 1,000 bulbs, of course, cannot all be tested the 1,000 bulbs made using method A and the 1,000 bulbs made using method B. So what happens is that we get a sample from the 1,000 bulbs, we get 100 bulbs from the 1,000 made using method A, and 100 bulbs from the 1,000 bulbs made using method B. As we can see, the sample that we choose must be randomly selected. Let's see a bit about randomly. Why do we say randomly? As we said, we need to keep the characteristics of the population in the sample. We don't want to pick out the bulbs that we know that, for example, look okay when made using method A, and the ones that they don't look very good when using method B, because it's like we want to get the result that method A is better than method B. We have to have no idea of what's going to happen. So we have to pick out, to choose bulbs, the 100 bulbs from method A and the 100 bulbs from method B, using no systematic pattern. We have to choose them in a random way. In this case, the population is the 2,000 bulbs. 1,000 bulbs made using method A, and the 1,000 bulbs made using method B. In an example, we have to make sure what the population is. As we said, the population is the whole that we want to study. If the population changes, then everything changes. Then the results are not valid. So we have, before we start analyzing data, we have to make sure that we know exactly what the population is. In this case, as we've seen, it is the 2,000 bulbs, the 1,000 from method A and the 1,000 from method B, and the sample is 200 bulbs. 100 bulbs made using method A and 100 bulbs made using method B. The 200 bulbs are the ones that are going to be tested for life duration. This sample, we said, must be representative of the population. If we have another sample of 200 bulbs, we would like to get similar results. We wouldn't want to reach a decision that depends on this sample. We would like to know that if we repeat the same experiment, then we can be confident that we are going to reach the same conclusions. So, the 200 bulbs are tested for duration, and we make a decision. The decision we make is based on this analysis. For example, let's assume that after the 200 bulbs were tested, the decision was that method A was better than method B. Then, if we repeat the same experiment, we would like to be confident that, again, method A would come out as better than method B. So, in this case, we would like to measure how confident we are that we are going to reach the same decision every time we repeat the experiment. In order to be confident, we need to use probability. In order to know that there is high chance that we are going to obtain the same results, we need to use probabilities. It is maybe more obvious how important it is in some cases to be certain for a result if we think about the problem of medicine. If a company introduces a new medicine and wants to find out if it's good for people to use it, it is important that when we analyze the data that we get, that there is a high chance, there is certainty, high certainty that the results we have reached, they are okay. We don't want in some point to find out that the company made a mistake, that the medicine was not good for people. So in some cases we are very strict. We want to have high certainty that something is okay, and in some cases wouldn't make it wouldn't be so important. Like if in this case the company wants to find out which method is most likely the best one, but if in the future it comes out that the chosen method is not the best one, then what would have happened is that the company would have lost some money and maybe change the method that makes the bulbs. It is very important, as we have seen in statistics, to make clear what the population is. If the population changes, if we want to derive results for another population, then we have to do the experiment again. The results obtained from the sample drawn from a specific population are only for this population, not for another one. So when we start an experiment, when we want to analyze data, it is very important to make clear what the population is, for what we are going to derive the results. When we draw a sample for the population, we would like to have a large sample, as big as possible, but of course, obviously we cannot have a sample very close to population. It wouldn't make any sense, as in that case one could analyze the population and make certain conclusions. When we cannot have the population, when the population is too large, then we need to obtain a representative sample. We said that it is important that the sample keeps the characteristics of the population. We want the decision that we are going to make based on this particular sample to be more close to the true one for the population. We want to know that if we repeat the experiment, if we draw another sample from the same population, that we are going to derive similar results. We want to measure how certain we are going to be in order to see if the conclusion we've made can actually be drawn for the population. That's how statistics and population blend together. Statistics is used to analyze data when we cannot have the whole population, we cannot collect data from the whole population. We analyze a sample, we get a small group of the population, and we derive results based on the sample for the population. Probability will give us the necessary mathematical foundations in order that we have the same measures, we talk about the same numbers. So if the experiment is repeated, or if somebody else wants to measure the same probability, we get the same results. So we can understand when we're talking about probabilities that we talk about the same thing. Now, probabilities originated many years ago. It actually comes from games of chance. People would like to measure how much chance they have to win something. But it actually was made a mathematical discipline much later on in the 17th century by Pascal and Fermat. Now, a summary of this lesson, what we have seen in this lesson. We have seen what is probability about. We have seen how we can use probability, why we need probability, why is it important when we study statistics to have probabilities, why we need statistics, why would somebody like to study statistics when it is needed, how probabilities and statistics are related, how probabilities is so important when we study statistics. We've seen examples in all these cases. We've seen examples to make clear, to define a population, to define a sample, to see where we need to measure our uncertainty or certainty about a result. Now, in the next lesson, we're going to see more theoretical background in probability, which is needed in statistics, which we are going to use later on for statistics. For more information on this course, if somebody wants more information, could see the web page of UNINETTUNO MedNetU project.